Welcome back, everyone. This video is about collections in F Sharp. And my goal for this video is to give you an overview of collections as opposed to a very intense guide on a particular collection type or uh, more than two, three dozens of functions which are available for a collection. I'll just focus on overview of collections, the various ways you can use collections and constructing collections, extracting values out of collections, and so on and so forth. Now, when working in F Sharp, you have two choices. One is the collections that are available in the standard .NET library, which is the way you use collections in C Sharp, the ones in system.collection and the ones in systems.collection.generic. The other is using F Sharp specific collections, which is array, list, sequence, map, and set. Now, for most of the cases, these four data types alone, these four collections alone are more than sufficient. Set is a very situational use case specific data set. Set is when you have needs or requirements which are close to mathematical sets and intersection and union and differences between sets. Otherwise, there's no particular use case, and you are always free to use the collections, especially after the addition of immutable collections in the .NET library. A number of collections you can use, for example, a stack, a queue. However, those can be simulated in F Sharp with a little effort, uh, but use your judgment. So I'll start with sequences. And when dealing with sequences, there are essentially two things. One is what sequences are, how to use those, and how to create sequences. Sequences are created using sequence expressions. So first of all, I'll talk about what are sequences. Sequences, aka INumerable in .NET, is an abstraction. It's not a data type of collections in itself. It's not a data type of collection in itself. It's a it's an abstraction. It's an and that abstraction is for anything which you can enumerate over. You can enumerate over an array, a list, a tree, a binary tree, a AVL tree, a dictionary, a string, a byte array. Anything which you can enumerate over is an INumerable. So the underlying data structure or the underlying collection declares that I can be enumerated via an INumerable, and that is what a sequence is. So sequences are not data structures or the containers for data themselves. But when we program in an abstract manner, a lot of programming in F Sharp, the abstract programming in F Sharp, is based on all sorts of high order functions for sequences. So loosely put, there you look at a sequence as a list. It's not a list. You shouldn't really treat it 100% as it's a list. But from an abstract point of view, you deal with sequential items, and that's what a list or an array are also. Now, I've copied this section into the code, so I'll quickly run you through. So, sequence expressions allow you to create sequences, and there are various ways you can create sequences. Practically, you will not be really doing all of this a whole lot because you refer to something as a sequence more often versus creating sequences for fun. You don't really create sequences, you refer to things as sequences. So, and the syntaxes that are available here are usable in many cases in F Sharp, for from loops to creating lists to sequences. So if you get friendly with the way this is sequence expressions work, it'll allow you to learn various other things rather quickly. So this will create a sequence from 1 to 3. This will create a sequence from 1 to 7, skipping by 2. So this is x dot y dot z, x to the range is x to z, and skip is y. This is with the for loop and the lambda. So you create 1 to 4, and keep squaring each value. The same thing, skipping and squaring each value. This is same as the again the top mechanism, but you are using a yield keyword. This is very similar to the yield in C sharp, where you create functions to generate enumerables. So for each iteration, the function yields a value, and that yielded value becomes available in the enumerable, and same as the above. So a lot of things are syntactically very close. They don't really do a whole lot. This is slightly interesting. There's an outer loop, there's an inner loop, and x and y is we are generating a tuple for each inner iteration. So we are generating a sequence of tuple, and this is a loop and a condition. So if you look carefully, we are doing an outer loop, and in the inner condition we are saying n only when n is an even number. So you are generating a sequence out of a range. One small point that I wish to make here is, which is completely unrelated so far this discussion is concerned. Anytime in F sharp you see something like this, uh, something, and a bracket starts and a bracket ends, it is an expression of some form or the other, which comes out of what is known as computation expressions. It's a fairly advanced concept in F sharp. We will not talk about it for a fairly long time. You have to have your nearly all the basics in place before you can even begin to start dealing with computation expressions. And you also have to have your fundamentals clear about a lot of functional patterns, because computation expressions are about bringing uniformity in the way various abstractions and functional patterns are used. So, but what I'm trying to highlight here is that the more anytime in F sharp you see something like this, two very common examples, rather three very common examples, being sequence, SEQ, which is for generating sequences, async for asynchronous programming, concurrent programming, and so on and so forth, and query for writing, which is C sharp's or rather F sharp's version of query within the programming language. So these are the most commonly three ones you will encounter. We will also create our own computation expressions in future for options, for results, for monads and whatnot. But right now, just remember that this syntax is coming out of a computation expression which is dedicated for sequences, right? So these are various ways you can create sequences, and I've also given everything on the blog itself. And you can iterate over sequences in a number of ways. So if you have a sequence like this, you can run a for loop. A loop like this, you will not be using a loop like this on many occasions. It's a sequence of tuples, and this is how you can destructure and run a loop. So you can run loops, but that's not a very common thing in F sharp. Nothing is stopping you, but you can always do that. This is an example of a loop of a sequence of integers, and you're iterating over that sequence. This is a sequence of tuples which comes out from the previous example, and you're iterating over. You are via pattern matching, you are deconstructing and looping, both combined. Okay, this is an important example that I wish to share with you, and let me just copy this. Now, the point that I'm making here is on the blog is that sequences offer a better abstraction. So imagine you are creating a record type record type student with name, age, and marks. When such a data type is created, you are enforcing the fact that marks should always be an array. While in all likelihood, you don't care if the marks is coming out of an array, if the marks is coming out of a list or a sequence or a binary tree. Or what you care about is that it's a sequence actually. So with a lot of functions and with a lot of data types, it's best to keep them slightly open-ended by using sequences. And this is what I'm trying to give an example of here, that if you make it like this in sequence, you can always use an array, you can always use a list, or you can always use a sequence or anything which is IEnumerable / sequence. So when you keep your data types open-ended, function signatures, and by open-ended I mean slightly open-ended, it's not open-ended as in past anything, but if you have a function and the core purpose of that function is to enumerate over something and then do whatever that function has to do, it's best to create a function. I think I've given an example here. Yeah. So find max can be written as operating over a list of numbers versus find max which operates over a sequence of integers. I meant list of integers. So using sequences as an abstract higher data type versus a very specific implementation which is array or list or anything which is sequential in nature, it's kind of limiting. So be careful of such simple issues when designing your function signatures and data types. All right, so now let's talk about arrays. Arrays are fixed size in F sharp. Once created, you can't change the size of arrays, and arrays are created using the list formatting only, except the pipes are added. Okay, so this will become a list, and if you add pipes, it becomes an array. Okay, and again you can use sequence expressions, do whatever, use sequence expressions, except add these, remove these, and this becomes a list. Add these, this becomes an array. Replace this with a curly brace, it becomes sorry, over here, not in the other cases. If you replace this with just the square bracket, it becomes a list. If you use sequence, it becomes a sequence. So the underlying expression remains same. The outer decoration declares what you are dealing with. So these are different ways you can create an array. You can create an array with 3 elements all set to 0. Arrays are slightly unique in a way that arrays allow mutation, which I wish was not the case, but that is the case. Arrays allow mutation, so you don't have to declare anything with any fancy binding. You don't have to do anything special. The moment array is created, it is mutation ready. You can mutate arrays. My take is that arrays are typically used where you are writing performance centric code. That's where arrays are most heavily used, where you are writing low level layers, where you are writing perhaps network interaction, TCP server, and so on and so forth. And in those areas, mutation is part of the recipe. You need mutation because immutability and creating new things for each round is a significant overhead for lower layers. And so this creates an array so these are two fancy functions. This creates 3 elements with a default value. This creates 3 elements with 0 only. And this is how you can print different arrays that we have created. Okay, this is an example of how to access values. You can access array by square bracket and index. Indexes are always zero bound. You can call the get value method. You can set value like this. You can set value like this also. So set value is value, and followed by value comes index, which is slightly counterintuitive. So beware of that. And this is a for loop to print an array. This is array.iterate method, that for each member of the array, this lambda will be called or a function will be called. So commonly useful for side effects on arrays and lists and so on and so forth. So now comes lists. This creates an empty list. Just the pipe is gone, rest everything is same. This creates a fixed, not a fixed size, but a list with these elements. This is with range. This is with a for and lambda. And just get friendly with these two operators. And before I explain these operators, let me explain one important thing in F sharp, because otherwise you may run into either all sorts of performance issues or difficult to understand issues. Lists in F sharp are immutable and they are implemented as linked lists. So a quick discussion what a linked list is: there is a node, there is another node, there is another node, there is another node, and each of these are connected by a next pointer. So when you create a list in F sharp, what you're dealing with essentially is a linked list, which for you it is exposed as a list. And any operation, you have to be a little careful about what you are doing with lists. So if I need to add something at the beginning, all I need to do is create a new item and point it to the new next, and the new next is already the current one. So adding an item at the head is a very low cost operation, or rather the least cost operation. Adding an item at the end requires traversing right to the end of the list and then adding an item. So when you think of appending items in the list, be careful how you are appending. So because there is an efficient way of adding items in a list, and there are bad ways of adding items in the list, and I'll perhaps discuss performance related common pitfalls later. So there are two operators for list. One is known as cons operator, colon colon, and the @ is for concatenation. Cons operator always adds an item at the beginning of a list. Concatenate allows you to concatenate two lists like this or like this. So if you have to add anything at the end of the list, it's best is to use this methodology, because what it does is it's a continuation of this list, or it's a head of this list. So you have to visualize, it's not this list is getting added here versus this list is getting added here. So again, I'll do performance specific discussions later. So these are various ways you can create lists. Use cons operator, which is construction, to append items at the head of the list, or the @ operator to concatenate lists. These are the examples for accessing items. Again, zero based indexing. You can also use item method, which you don't really need to, because the square one is everybody is more friendly with the square syntax. You can loop over a list like this, or you can iterate for causing side effects and whatnot. You can do this. A very common thing you will encounter when working in F sharp is this pattern matching thing for list is, and I'll quickly explain what it is because there's a dedicated section I have for. So there's a list. The head, list.head, always refers to the first item in the list, and list.tail refers to whatever follows. So list.head is one item, list.tail is a list in itself. So if you have the first item and second to nth item, you have the entire list. And the reason it is useful is because in functional programming, a lot of techniques are which revolve around lists. They follow this pattern. So if you have a list, I'll not discuss this method right now because there's a dedicated section for it. So whenever you do pattern matching over lists, you basically deal with these two patterns: head, cons, tail. In the head, you get the first item of the head. In the tail, you get the entire remaining list. Or empty is if this list is empty. So you write all sorts of fancy algorithms and computations about for lists using this pattern matching. You match a list and you keep on iterating over the list in a recursive manner. And if there are items, you will hit this case, and if there are no items left in the list, you will hit this case. Okay. And so you can quickly see I've given more examples on the blog for tail recursive functions. Sets are just sets, unique value, and they are ordered. Ordered in the sense sorted, not ordered. Sorry for the wrong choice of words. Lists are ordered but unsorted. Lists are ordered basis the order in which you are writing adding items. Sets are sorted. It doesn't matter in which order you have added the items. You can also specify your comparator for comparing and comparisons and sorting and so on and so forth, but those are all advanced concepts. I'll not discuss those right now. So this is how you create an empty set. This is how you add a value to a set. If you add it again, nothing will happen. You can keep on adding values. You can create a set out of an array. And this is an example of if you have an array with duplicate items, it will translate into a unique value sets. You can create set out of a list. You can create a set out of a sequence. So think of a set as a list. I'm giving you a simplified version, not the correct version, which will always be sorted and will always have unique values. The use cases for sets are not too common. Set is a very mathematical concept and is used when you have mathematical use cases, when you are dealing with problems that require you to have sets. Okay. So this is a set, and this is how you can loop over. This is how you can do an iter for causing side effects. And maps are, like I said, your synonymous data structure for dictionary or hash table or hash maps, whatever you may. This is how you create an empty one. This is how you add a value or a key value pair. The key, the value, the second key, the second value. As a matter of fact, I'm repeating the key, so the value will be replaced. You can add many values. So each time you add value for an existing key, it will be updated. If the key is not present, it will be add or replace depending upon the presence of key. You can create an array of tuples and translate it. You can create a list of tuples and translate it. You can create a sequence of tuples and translate it. Okay. And once again, okay, here is how to find items and so on and so forth. So this is a map. So what I'm trying to highlight here is there are ways to deal with maps which are recommended, at least in my views, and the ones which I really recommend not to do. This should have been this. It seems to be a typo. What you are saying here is out of map M, get the value for key 1. In continuation, get the value for key 100, and this will cause an exception, not what you want. So you want something like this, okay? And so try find is giving you an option, okay? Try find, now x2 is an option, and there is the other method which gives you a bool, tuple of bool and value. So like I said, if I'm finding 1, x3 becomes true and 1. And if I'm finding y3, you get a tuple with whatever, we don't care what's the second part because the value isn't available, you get the false. And so use one of these two methods, whichever you find more convenient and or whichever fits best into your solution, as opposed to using this trick. This trick is it smells of C# tactics to me. Don't follow this path. This is for iteration, and this is your iter method for side effects, and so on and so forth. So, like I said, this video was supposed to give you a quick overview of what the basic collection types are there, and when there is a very special need for a very complex collection, you can always fall back to the .NET library of collections. All right, see you in the next one.